So, earlier this year, when we were simplifying square roots, we did prime factorization. You guys remember that? So, like, if we had the square root of 60, we would go and go, okay, 2 goes into 60 30 times, 2 goes into 30 15 times, and 3 goes into 15 5 times, and 5 goes into 5 once, right? If we had written 60 as being equal to 2 times 2 times 3 times 5, we usually didn't take the time to do that, but if we did, that's factoring. Okay? We're going to do the same thing here, except we're doing with an algebraic expression, not just with a number. So we want to get the factors out of an expression. So the first step is always look for a common monomial factor, or just a common factor. So what divides evenly into both of these? 3. So we'll factor the 3 out. So this is going to be equal to 3 times x squared, 3x squared divided by 3 would be x squared, minus 12 divided by 3 is 4. We'll deal with the rest of one like that in just a second, but for right now, we're just factoring out a common monomial factor. You've done this before. Marion, you look concerned.
Well, I'm just like, is that as far as it goes?
No, this one can be factored further.
Because I was thinking it could be x and 2, but I don't understand how you keep the minus.
Oh, well, if you wanted to factor this one completely, this factors to 3 times x plus 2 times x minus 2.
Okay. That's what I was
All right, what could we factor out of this?
4.
And?
2. X.
And an x. So 8x cubed divided by 4x is 2x squared. 16x squared divided by 4x is 4x. And 20x divided by 4x is 5.
20 divided by 4 is not 10.
Indeed. Okay, any questions about finding common monomial factors? Yes.
Do we have to put the equal sign?
Usually I write it on the next line down, so it's not a big deal, but I don't care much one way or the other. Yes?
Okay, look at the top equation. Isn't x squared minus 4 still equal to 3x squared minus 12? Like, what is the significance of a 3 on the outside? Like,
Wait a minute.
like, in a normal equation, that would generally be like...
So we're not doing an equation. We're simplifying an expression.
Oh, okay. Got it.
Okay? We're just rewriting that expression in another form.
I was thinking
Like
okay,
this equals this, and they're not the same.
3x
Yeah.
squared minus 12 equals 0, and then you divide all sides.
Right, like solving
Yeah.
an equation. Here, we're just rewriting the expression
Okay.
in a different format. All right. So, factoring binomials. Binomial means it has 2 terms. Okay? So, after you factor out any common factors, the only binomial factoring that can be done is the difference of 2 squares. So, notice, if we were to multiply a plus b times a minus b, and actually do that, we'd have a times a is a squared. A times negative b is negative ab. Then distributing the b times a is a positive ab. What's going to happen with those 2 terms? They're going to cancel each other out. They're going to add up to 0. And then b times negative b is negative b squared. So we end up with a squared minus b squared. So anytime you have something that is in this form, a squared minus b squared, it factors to a plus b times a minus b. So anything that starts in this form factors like this. So, for example here, x squared minus 25. That's something squared minus, well, what's 25 as something squared? 5 squared. So you don't have to write it when you're working it, but you definitely want to think it. This is x squared minus 5 squared. So how do we factor that? Well, it'll be x plus 5 times x minus 5. No.
The math of this is like this way for the rest of the year. Are we gonna have like any more like super hard math? Like,
Super hard math.
Not your definition of super hard math, but like our definition.
We're doing some algebra review stuff. It's not going to be super hard.
Yes. And this is on our test?
Yes.
Oh, that's super nice. I thought our test was about circles.
And this. Your quiz tomorrow is just on circles.
Do we just have one quiz, one test?
Yes.
Tomorrow? Oh.
Quiz, I'm sorry, Thursday. Quiz Thursday, test Tuesday. All right, for this one, again, we want to think of it as something squared minus something else squared. Now, can we factor anything out of this?
No.
No. 3 won't divide evenly into 64. So how can we rewrite 9x squared as just something squared? 3x quantity squared. Minus, how can we write 64? 8 squared. So this is going to be equal to 3x plus 8 times 3x minus 8. Yes?
How do we know that in the first, not the first equation that's already written, but the first equation that you wrote down when it says negative 8 squared, how do we know that it's not talking about negative 8 times negative 8? But like...
Because what I have is a squared minus something else squared. Now, could this be negative 8 squared? You could do that, but if you substitute negative 8 in the place of positive 8 here,
it would become positive.
it'd be 3x minus 8, and 3x minus a negative 8 would become
Positive.
right,
Oh.
which is exactly what we have here.
Oh, okay.
All right, for this one, what do we need to do
We
first?
can take 3
Yeah, we're going to factor out a 3. Sammy?
Can we take out 3x? Or no?
Actually, we should take out a 3x squared. You always want to factor out the largest monomial that you can factor out. So this would be 4x squared minus 9. So that's 3x squared times, how can we rewrite 4x squared as something squared? 2x squared. And again, I don't expect you to write this part out. Absolutely. So it's 3x squared times 2x plus 3 times 2x minus 3. Any questions? All right, page 2 then. Factoring trinomials. We've done some of these this year. We've always done ones where the leading coefficient was 1, where there's no number written in front of the x squared. You just have 1x squared. All right, notice that if we multiply x plus a times x plus b, we get x squared plus bx plus ax plus a times b. Everybody good with that? And that if we look at this middle part together, that's b times x and a times x, right? We could rewrite that as a plus b times x. So when we're trying to factor, our goal is to find two things that add up to be the middle term and multiply together to be the last term. That's why you do target product and target sum.
Can you repeat that?
Yeah, so
Just the last part where you said we have to add and multiply.
So if you're trying to factor something, you're going to look for something that adds up to be the coefficient of the middle term and multiplies together to be the last term. All right? So here,
7 and 3.
yeah, we want two numbers that multiply together to be 21, that add together to be 10. It's 7 and 3. So that's x plus 3 times x plus 7. And again, we've done some of these. You should be able to zip through these pretty quickly. What does this factor to?
X plus 6 times x plus 2.
Right? Ooh, suddenly we have a negative involved. What's going to have to be true for both of our numbers since they need to add together to be 15 but multiply together to be negative 8?
They're both negative.
They both have to be negative.
Negative
Negative
5.
5 and negative 3.
Right.
Okay, Jackson.
This one, same way. I need two numbers that multiply together to be positive 35 but add together to be negative 12.
Negative 7 and negative 5.
Yeah, negative 7 and negative 5. The order is not important. Now I want two numbers that multiply together to be negative 24, but add together to be negative 5. It's a little harder, isn't it?
X minus 8 times x plus 3.
Very nice.
Wow.
So here,
X plus 9 times x minus 4.
yep, x plus 9 times x minus 4. What do I need to do first on this one?
Get rid of the divide by x.
Do what? Get rid of an x?
Oh, square.
Yeah, and let's not say get rid of because we're not getting rid of it.
Divide.
Factor out an x squared. So that'll be x squared minus 6x minus 40.
It's gonna be 4 and negative 10.
Okay, so x plus 4 times x minus 10. Very good. So don't forget to look for a monomial factor first. People tend to get in kind of a groove and they're just going and they forget to factor that out first. All right, what if the leading coefficient is not 1? Well, sometimes you can make it a 1 by factoring out a common factor. So for example, on this one, yes?
For the last question, why could we have divided by 2x squared? Oh no, because one of them was just an x.
All right, so for this one, what can we factor out of all of these?
2.
A 2. And once we do that, now we do have a leading coefficient of 1. So we just factor it as normal. We want two numbers that multiply together to be negative 35 and add together to be 2.
7
All
and
those
negative
are
5.
negative
7 and negative 5. You can also do that when the leading coefficient is just negative 1. You can factor a negative 1 out of all of this. So that'll be positive x squared minus 6x
Why would you say 12?
plus 32.
What would be 12x?
Oh, sorry. Thank you. I told somebody once I almost never mess up on concepts, but I mess up on numbers a lot.
At least you're not one of those teachers that says, "Oh, I was just checking to make sure you were paying attention."
Yeah, it's almost never true. So that I can. So how does this factor?
Negative 6 and negative 8.
Yeah, pardon?
Negative 4 and negative 8.
Negative 4 and negative 8. So x minus 4 and x minus 8. And occasionally, I don't normally do this. I usually just leave it like this. But what they'll do is they'll go ahead and multiply this negative 1 back through one of them and say that this is 4 minus x times x minus 8. Because the negative 1 times x minus 4 is 4 minus x.
You have to do that.
No. I'm perfectly satisfied with you leaving it like this. Now, what if you can't do that? Well, you have two choices. You can do some guess and check, or you can do something called splitting the middle term. Do you guys know how to, have you heard of that before?
I thought we did that before, yeah.
Okay, so let me remind you of how to split the middle term. What you do is you take the first coefficient and the last constant and multiply them together. That's negative 45. That becomes your target product.
Why did you get 15?
Oh, sorry, it was 5. I was thinking of the answer. So this is negative 15. So you want two numbers that multiply together to give you negative 15 and add together to give you negative 14. I'm sorry?
Oh, wait, what is it?
We want them to multiply together to give us negative 15 and add together to give us negative 14. Negative 15 and positive 1. So what we're going to do is split this negative 14x into negative 15x and a positive 1x. Then what we do is we take the first two terms and factor out any common factors, and the last two terms and factor out any common factors. All right, I can factor a 3 and an x out of this, and when I do, I'll have x minus 5 plus, the only thing I can factor out of this is a 1, right? 1 times x minus 5. So notice I have a 3x times an x minus 5, and I have a 1 times x minus 5. So the simpler way to write that is 3x plus 1 times x minus 5.
Do we have? Oh, never mind.
Yes?
Is it always going to be like that? Where you're multiplying by the same thing?
Yes, if you've done it correctly, splitting the middle term will always work out that way.
So it's good.
Because if these two things are not the same, when you factor out the common factor, something's gone badly wrong.
Or we can reset.
Yeah, like start over.
Race.
Okay? You can also do this by doing a little guessing and checking. Let me just show you real quickly. You don't have to write this down if you don't want to. But I know if I have two things that multiply together to be 3x squared, what's the most likely thing for that to be? Two things that multiply together to be 3x squared. 3x and x. And now I know I have to have two things that multiply together to be negative 5. It could be negative 1 and positive 5, or negative 5 and positive 1, and play around with it a little bit until when you multiply it out, the middle term turns out to be negative 14. So if I go, okay, negative 5 here, that gives me a negative 15x, and a plus 1 here gives me a positive 1x, that adds up to negative 14x. It's faster if you do it that way, but sometimes the guess and check is just so long, there's so many possibilities that it's hard. On ones like this, where these are both prime numbers, I tend to do guess and check rather than split the middle term. When they're not, I tend to not do splitting the middle term. Yes?
Will we get counted off on the quiz if we were doing guess and check and we like couldn't show as much work as
No. All I care about is that you get this answer.
Okay.
Okay?
Will there ever be a question where we have to do one or the other?
No. I never require that you use a particular method for solving by factoring.
Lexi said that she did a math test. She got like answers right, but she got counted off because she didn't show like the 4 steps that she was supposed to show.
Okay.
Yeah.
It depends on what it is. There are some things where I'm like, yeah, you need to show all
She
the.
said there was one it was like you have to write out like 4 plus 2 equals 6, and she didn't and got her counted off.
Yeah, it happens. All right, so let's take a look at this one. So can I factor any common factor out? No. So either you're going to have to do guess and check, or you're going to have to do splitting the middle term. Since 21 is not prime, I'm going to split the middle term. If it's prime, I'll do a little guess and check. It doesn't take terribly long. So multiplying 2 and 21 together, I get 42. So I want two numbers that add to 17, but that multiply to be 42. 3 and 14. Is 14 times 3 42?
I think so.
All right.
Because 3 times 13 is 39.
And 3 plus 14 is 17. All right. Which one do you want to do first? It really doesn't matter. Yes, ma'am.
Does it matter which side you put it on?
I'm sorry?
Does it matter which side you put each one on?
Which
Like,
side?
Like, if I said 2x squared plus 3x.
That's what I was just saying. It doesn't matter which one you want to do first. You can do the 3x first or the 14x first, whichever floats your boat. So which one do you want to do?
14.
Okay. Plus 3x plus 21. So we've just split the middle term. Now we want to factor the first two and then the second two. What can I factor out of the first two?
2x.
2x. And that'll be x plus 7. What can I factor out of the second two?
3.
A 3. It should always work out that we get the same binomial. So it's 2x plus 3 times x plus 7. One more. Can I factor out any common factors? No, but always look for that. Since both the leading term and the constant term are not prime, I will absolutely split the middle term here. It'll be a lot easier. So 12 times negative 18. Icky.
Negative 316.
216.
My bad.
You were close. So I need two things that multiply together to be negative 216 and add together to be negative 19.
Are we getting negative 19?
That's my middle term.
Yeah, so they're both negative? No, one's negative.
One's got to be negative, one's got to be positive.
7 and positive.
I'm sorry, what?
Negative 27 and positive 8.
Negative 27 and positive 8?
Right?
Does 27 times 8 equal negative 216?
I think so.
See, that'd be negative 160 plus 7 times 56. Yeah, that's impressive.
I did the math. It wasn't the brain. It was the paper.
Right, but you came up with it pretty quickly, right? The negative 27 and the 8?
Oh yeah, I first I did 4, so that but
You're like, that's not going to work.
yeah.
Okay. So let's do 12x squared. Oh, let's do the positive 8. And then do the negative 27x minus 18. So what can I factor out of the first two terms? 4x. And that'll be 3x plus 2. What can I factor out of the second two? A negative 3. How about a negative 9? Which will give me positive 3x plus 2. Again, if you do it and you don't get the same binomial in parentheses, go back and see if there's something more you can factor out. So this would be 4x minus 9 times 3x plus 2. Okay, it's not bad. You have to be good at factoring to do a lot of stuff in Algebra 2.
A little bit.
I like that.
Just
Yes. Now I've got a worksheet for you.